Welcome to Math is Fundamental. Today we're going to be talking about similarity transformations. All right, so let's start with an example. So we have triangle DEF with vertices, D, E, and F. So we want to plot those on our graph first. So 2, 0 is going to be D, 1, 4 is our E, and F is at 4, 2. All right, so here is our original figure. Now it says, what is the image of triangle DEF when you apply the composition D1.5 composed with R y-axis? So remember, back a couple of videos we did compositions of isometries. We always want to do the second transformation first. So our y-axis is reflection over the y-axis. So that's going to be our first step here is we want to reflect this over the y-axis. It says draw the first one in red, the second one in blue. All right, so my first one is going to reflect, and we always want to label them. 1, 2, 3, 4, 1, 2, 3, 4. Again, if you need a little refresher course on reflections or dilations or anything in this lesson, you can always go back and watch my previous lessons. All right, going here. So here is our first step, which was our reflection across that y-axis. And you always want to double check and make sure that it looks like what it's supposed to look like. All right, now we want to do a dilation of 1.5 and do that in blue. So what this means is from the origin, my length from the origin to any point is going to have to be multiplied by 1.5. So 2 times 1.5 turns to 3. So here would be my D double prime, because now the length between the origin and D double prime is 3. The origin and E, my length goes, well, let's see, we went over 1, 2, or up 1, 2, 3, 4 over 1. So if I take that and multiply it by 1.5, I'm going to get over to 6 and to 1.5. So it's going to be kind of here, E double prime. Try to reach up to the top there, up at 6 and 1.5. All right, and then to F. So we want to, again, go straight through, and let's see, if I had 4, 1.5, and 4 is going to be 6, and then 1, 2, 3. So we have 6, 3, there we go, F double prime. So here is my image after those two reflection and dilation, so after my composition of those two transformations. All right, example number 2, what is a composition of rigid motions and a dilation that maps RST to PYZ? So again, I'm going to color code these. R maps to P, and then S maps to Y. So I'm looking at the order of the letters in my statement. And then T maps to Z. So T has to go to Z. It's very important that you do this little color coding trick, or whatever trick you need to do to see that exactly where these points need to go. Otherwise, you might miss something like a reflection or a rotation in your image. All right, so here I need to figure out how to get from one to the other. Well, the easiest way to do this is to look at lines between your 2 points. So if I go like this, and sometimes it's a little easier than others, sometimes it's not. It looks like every single point goes straight through the origin, which is good. We're going to use the origin as a point of focus. Now, if I also need to rotate this thing 180 degrees. So let's start by a 180 degree rotation about the origin. And you know what? Sometimes you might start with something and it might not work out, and sometimes it does. You just gotta jump in there and try whatever you think you might want to do there. So if I rotate R 180 degrees, it's going to go to here. S is going to, so 3 over 1, so 3 over 1, here's S prime. And then, oops, so I'm going to make it red to match my red. And then my green, 3 and 1, is going to go here, T, oops, there we go, T prime. Okay, so now I have this middle triangle, and if you look, now that I rotated it 180 degrees, my colors, my color-coded points match up a little easier to the ones I need to end with. All right, so now if we look, my length from the origin to T goes over 3 down 1, and the length from the origin to Z goes over 6 down 2. It doubled in length. All right, and if you want to think about it another way, the length of TR is 2, and the length of ZP is 4. So this thing, our image here, has doubled in length to get to our resulting figure. So I think at this point I'm ready to write my composition. So first I started with a rotation of my figure 180 degrees about the origin. And I'm going to compose that with a dilation of scale factor 2, and it's about the origin, which is kind of our default, so we don't need to note it. All right, I started with triangle RST, and I'm ending with PYZ. Now your notation, your composition might be a little different than mine, but that's how I ended up there. All right, similar figures. So here we have a similarity transformation. If we think way back to when we learned about similar figures have the same size, or same shape, but different sizes. Here, if you look at what we're doing on our graphs, our pre-image and our image have the same shape, but different sizes. So here we have a composition of rigid motions and dilation that maps pre-images to similar figures, which means same shape, but different size. All right, two figures are similar if and only if there's a similarity transformation that maps one figure to another. So let's look at our last example here. Is there a similarity transformation that maps triangle JKL to NOT? If so, identify it and write a similarity statement. So first thing we want to look at is corresponding sides. 6 corresponds to 9 because those are the two smallest sides. And let's see, 12 is the largest, corresponding to the largest, which is 18. So we want to figure out first if these are similar figures. And to do that, we want to take ratios of the side lengths. We want to see if it has a common scale factor. So 6 over 9, 10 over 15, and 12 over 18, and reduce them. So if I reduce this by 3, I get 2/3. Reducing it by 5, I get 2/3. And reducing it by 6, I get 2/3. So yes, triangle JKL is similar to triangle NOT by side similarity. So a little bit of a jump back into last couple units there. All right, and I know I have a scale factor of 2/3. So now I can write a similarity transformation. So my transformation, and now we don't have a graph to talk about different points. So in this case, we're just going to kind of explain what's going on. So this is going to be a composition. If we imagine this on a graph, what would it be? It would be a composition, well, this mapped to this one, here mapped to here, and this one mapped to here. So if you look, our figure has to rotate a little bit, and then it has to dilate. So composition of a rotation and a dilation with scale factor. Now here's the trick. It only has a scale factor of 2/3 if it got smaller. If it got bigger, it has a scale factor of 3/2. So we have to really talk about which one we are starting with. So we have to state that. So let's see. It's scale factor, I'm going to say, of 2/3 from, so from NOT, triangle NOT, to triangle JKL. So we want to specify which direction we're going, so which one we started with and ended with when we say our scale factor, or it could be different. All right, and that concludes our lesson for today. Thank you so much for watching, and remember, math is fundamental.